Physical and chemical equilibrium. We have learned in our last lesson what is an equilibrium, what is a state of an equilibrium, and now we will take certain examples in the physical and the chemical systems. In a physical system, we can have a equilibrium between a liquid state and its vapor state. Suppose you take the water in a closed vessel. So if I fill up a vessel here with the water, so what you will see after I close this vessel over here, if you have an open vessel, then you cannot have a equilibrium. You cannot obtain an equilibrium, right? Because we have a equilibrium between a liquid and its vapor state. So you can get it only when you have a closed system. So if you have a closed system and that contains some water, right? And now what we see initially, once you put this liquid in the in this container in a closed vessel, so you will see that more of the liquid molecules, they will be entering into the vapor state, correct? So evaporation will take place. So a lot of water molecules will, they will go into the vapor state. And in the vapor state, these vapor molecules, they have the random motion and they are going to move in all possible directions, correct? And they will strike with the walls. They will also strike with the, the surface of the liquid over here. And then this, vapor molecule, when it strikes on the with the liquid surface, it will lose energy and it will go back into the liquid state. So actually, you will find that once you take the water in a closed vessel, evaporation will be, much faster because you have, very less amount of the vapors there. So what you find here, initially you will find that rate of evaporation, correct? The rate at which the water molecules will be converting into the liquid. This rate of evaporation will be fast. And rate of condensation, initially it will be, very, very low because we have very less amount of the vapors. So you can say the condensation over here is, rate of condensation will be very slow. And it will take some time, with the time what will happen, more and more these liquid state will enter into the gaseous state, and therefore what we find the rate of evaporation and the condensation at some point it will become same, correct? Initially evaporation is more, evaporation is very high, condensation is slow, but with time what's going to happen? So point will reach when both rate of evaporation will be equal to the rate of condensation. That state, is called as a equilibrium state, right? That means when you obtain an equilibrium state, there is no more further change in, the pressure of this gas, correct? What you call as a vapor pressure, right? So the vapor pressure, that means the pressure exerted by these, vapor molecules, that will remain constant. Initially, you will see that more and more liquid will enter into the gaseous state. So rate of evaporation is very high. Therefore, the vapor pressure will keep on increasing until the evaporation becomes equal to the condensation. And once you attain an equilibrium state, this vapor pressure, the pressure exerted by the vapor molecules, will remain constant because in the same time, in a particular time period, same number of molecules will be leaving the liquid surface. And you will have the similar number of molecules entering from gases to the liquid state. So that means once you obtain an equilibrium state, means once you have the rate of evaporation equal to the rate of condensation, the vapor pressure of a particular liquid, that will remain constant, that will not change further. We can also have an equilibrium between the solid and its vapor state. And one such example is the iodine. The iodine in the solid state can undergo the sublimation, means it will directly convert into the vapor state, right? And if you take a iodine crystal over here in this conical flask, and then we close this vessel, this conical flask here. If you close this conical flask, what you will see? You will see that this iodine from the solid state will enter into the vapor state. So some iodine vapors will be there, and this iodine, it will give some pink color, correct? The conical flask will attain some pink color. You will observe a pink color due to the formation of the iodine in the vapor state, right? And this pink color, intensity of the pink color, you will see that it will keep on increasing. But what happens here, since this is an equilibrium process, iodine from the solid state goes to the vapor state, and if you keep it a closed system, if you have a complete closed system, the iodine doesn't escape into the atmosphere, then you can have an equilibrium here. Iodine from the solid state will go back into the iodine from the vapor state will go back into the solid state, right? So that means after some time you will see that both rates will be same. Rate of sublimation will be equal to the rate of solidification here. When the solid iodine converts to the vapor state, and the vapor iodine, it converts back to the solid, and after you attain the the equilibrium state, you will see that there is no more change in the color of this conical flask. The intensity of the color, that will keep same, that will remain same. Equilibrium can be obtained in the chemical systems, in the chemical reactions. Suppose you take here a reaction between the hydrogen and the iodine. These are the two gaseous systems, okay, hydrogen and the iodine, and when they react, what they form, they actually form the hydrogen iodide. HI is formed, and let's say balance it. And if you take this system, you take a system in which actually you mix hydrogen with the iodine, and we have suppose here a closed system. So what actually happens over here, we find that HI again, it goes back into the iodine and the hydrogen. It decomposes into the hydrogen and the iodine. So you can get actually an equilibrium in a chemical system also here, but provided we have a closed system, because we have gaseous components here. We have a hydrogen as a gas, iodine as a gas, HI is also a gas, okay? And this is a reversible reaction where hydrogen and iodine, they combine and form HI, and HI goes back into the hydrogen and iodine. Initially, when you take a vessel, a closed system, and you fill it with the hydrogen and the iodine gases, and you can observe the color, because iodine in the gaseous state, we have learned that it is purple, or you can see the pink in color, right? The intensity of the color here will be high initially. It will be high because we have a higher concentration of iodine, and once this hydrogen and the iodine, they combine, they form HI. HI is colorless, right? This is a colorless gas. This is also a colorless gas. So what you see initially, when you mix the two, hydrogen and the iodine, the intensity of the this pink color will be high, and with the time, what you see that rate of forward reaction will be high, right? So that means the intensity of the pink color will decrease, and after some point, after some time, when you attain the equilibrium, when both rate of forward reaction and rate of backward reaction both are same, then the intensity of the this color will not change further, right? It will not change further. That will remain constant. So that means this system has attained an equilibrium. We can also get an equilibrium between the a calcium carbonate, which is a very hard solid. If we strongly heat it, it converts into the calcium oxide and carbon dioxide. This is solid and this is a gas. When you take this system in a closed vessel, so what happens here? The carbon dioxide, will again react with the calcium oxide, and again it forms a calcium carbonate. So when you take this calcium carbonate and you heat it strongly, right, in a furnace, so what do you see that we find the calcium carbonate, it decomposes into the calcium oxide and the carbon dioxide. And you see when you take this system here, when you take a calcium carbonate, the rate of the decomposition is very high, and rate of the combination of the calcium oxide and the carbon dioxide is initially it's very low. After some time, when with the time, what you find, you see that rate of forward reaction, that becomes equal to the rate of the backward reaction. So that means both the systems will attain some equilibrium, correct? So these are certain examples in the chemical system where you have an equilibrium. Hope you got it. Thanks for watching the video. Bye for now.